Hello everyone, good evening. I hope you are really enjoying the week, though it's coming to an end soon. So today we'll be looking at a topic in chemistry called the rate of reaction. But before we do that, please like and share the video, and also do not forget to subscribe so that whenever I post a video, you'll be the first person to be notified. Okay, let us quickly look at the definition of the rate of reaction. What do you understand by the term the rate of reaction? The rate of reaction is the change in concentration of products or reactants in a given time. The change in concentration of the products or reactants in a given time, which means that the rate of reaction can be expressed as in rate of reaction is equals to increase in product over the time interval or the time taken, time usually in second. Now the product could be volume, it could be concentration, it could be mass, it could be anything. You see that, eh? So now when talking about the rate of reaction in terms of product, it increases, the product increases as the reaction is taking place over the time taken there. But however, the rate of reaction can also be expressed as rate of reaction is equals to the decrease in product. As the reaction is taking place, the number of products are being reduced, the amount of products are being reduced. So decrease in product over the time taken. So that's how you can calculate the rate of reaction using the expression there. Now, this rate of reaction, or the speed at which the product are formed, or the speed at which the reactants are being used up, is affected by a number of factors. So let us look at the number of factors which affect the rate of reaction. The factors which affect the rate of reaction. Very quickly, we're going to look at some examples on how to tackle the questions on this. What are the factors which affect the rate of reaction? So factors affecting the rate of reaction. What are the factors which affect the rate of reaction? One, we have a catalyst. Among the factors which affect the rate of reaction, we have what is called the catalyst. Now, what is a catalyst? What is a catalyst? A catalyst is a chemical substance which speeds up the rate of reaction and remains unchanged itself, chemically. A catalyst is a chemical substance which speeds up the rate of reaction and remains unchanged itself. So it could be anything, it could be an element, sometimes a compound, which just speeds up the rate of reaction. In other language, we say a catalyst lowers the activation energy of the reaction. Now, the issue of the activation energy is the minimum energy required for the reaction to start. So that energy required for the reaction to start is reduced by if a catalyst is introduced there. So a catalyst speeds up the rate of chemical reaction, but itself does not really take place. It remains unchanged. So a catalyst is one of the factors which affect the rate of reaction. Now, apart from the catalyst, we also have what is called the change in temperature. Change in temperature. Change in temperature, that means it could be increasing or lowering the temperature. Now, as the temperature increases, the rate of reaction also increases. When the temperature reduces, the rate of reaction also reduces. Now, how does temperature really, affect the rate of reaction exactly? How does it do that? Now, when the temperature is increased, the particles in the reactants there, they gain kinetic energy, which makes them to move faster and collide quickly in the reaction chamber. And hence, speed up the rate of reaction. For a reaction to take place, the reactants must collide. If these are the reactants, when they meet, that's when the reaction takes place. So if the temperature is increased, these particles gain the kinetic energy, which is the energy which enables them to move fast and makes them to collide frequently, speeding up the rate of reaction. While when the temperature is low, they have less energy to move. They move very slow, and hence reducing the rate of reaction. So temperature, the change in temperature, reduces the rate of reaction if it is low. When it is high, it increases the rate of reaction. The other factor which affects the rate of reaction is the change in concentration. Concentration is another factor which affects the rate of reaction. Concentration, we're really talking about the amount of reactants or products, in this case present in the reactants there. That's concentration, the amount of solute in the solvent or in a liquid in that case. So now, how does the concentration affect the rate of reaction? Now, when the concentration is high, the rate of reaction also increases. When the concentration is high, the rate of reaction increases. How does that take place? If this is the beaker or the reaction chamber, then we have a lot of reactants. See that, eh? A lot of reactants there. We imagine those are the reactants there. We have another reacting chamber there, where we have less reactant there. So we imagine, so here the reactants are concentrated. They are highly concentrated, whereas there the reactants are lowly concentrated there. So where the concentration is high, the particles will be traveling very little distance to meet. For example, for this particle to meet this one, to meet that one, it will travel a short distance. Therefore, the reaction will be increased because the particles are traveling a little distance to collide. Whereas where there are less concentration there, particles will be traveling a quite long distance for them to meet. So when the concentration is low, the rate of reaction is lower as well. When the concentration is higher, the rate of reaction is also higher. So concentration is one of the factors which affect the rate of the rate of reaction. Apart from these three factors, the last one I'm going to look at is the surface area. How does the surface area affect the rate of reaction? The surface area, we are talking about the area exposed to the reaction. Now, the smaller the reactants, the higher the reaction. Meaning that if this is the reactant there, we also have another reactant of the same type, but this one is smaller, this one is bigger. You can see that then. So the smaller the reactant, the bigger the surface area exposed to the chemical reaction. The bigger the reactant, the less the surface area exposed to the the reaction. So when it is small, when it is small, meaning that it has a bigger or higher surface area exposed to the rate of reaction. When it is big, meaning there's a very small surface area exposed to the rate of reaction. So the smaller the particle, the higher the rate of reaction. While the bigger the particle, the lower the rate of reaction. You get that then? So these are the common factors which affect the rate of reaction. Now, the rate of reaction can be expressed on, can also be interpreted on graphs. The rate of reaction can also be interpreted on graphs. Now, when interpreting the rate of reaction on graphs, we have some, few things which you need to take note. Okay, that's the XY plane there. So here, usually we put time hours in seconds. Then here, it could be volume, could be mass, it could be concentration. Here changes. So that is volume in centimeters cubic, for instance. You see that there. when starting the reaction where it's 0, 0, before starting the time is 0, and also the concentration, the volume is 0. So when the reaction starts, the number of product will start to be produced, and the reactants will start to be used up, fading up until the line looks like that. Now, the steepest side of the reaction shows the fastest part, where the reaction is really fast. Now, as time goes by, the line becomes flat slowly until it is completely flat like that. So this part where the line is flat shows that the reaction has ended. The reaction is not taking place. Here, the rate of reaction has started with speed. It is increasing, it is decreasing as time goes by until it stops. So when the graph flattens there, when the curve flattens, it means the reaction has stopped. You get that, eh? So questions on the rate of reaction can be brought like that, as we can see on the diagram there. The table below shows the volume of carbon dioxide recorded at various time intervals. So this is time here, and this is the volume of carbon dioxide being produced. The first question is plot the graph. How are we going to plot the graph of that table? We draw the X or Y. Usually you need to use the graph paper. They'll give you a graph paper. You must have a graph paper to use. But here I'll just improvise. I'll just use the board so that it become fast. Okay, this is the starting point. As usual, this is time in seconds. Then here it is volume in centimeters cubic, as you can see there. Volume of carbon dioxide. So time is starting from 0 up to 25. You have 0, 5, 10, 15, 20, then 25. Then volume is starting from 0 up to 40. So we have 10 here. You can use any numbers to count. Okay, we have 20. 30, we have 40, like that. Now, for us to start plotting, the first point is 0, 0. So 0, 0, which is there, you can see that there. The second point is 5, 15. So time is 5. Then the volume is 15, which will be between 10 and 20 here. So now where they meet, that is where my point would be. So this is where my point is. You can see that, yeah? Then the third point is 10, 25. When it is 10, 25 obviously is between 30 and 20. That's what 25 is. So my point is there. You get that? Then you have 15, 35. 15, 35. 35 is there. Then 15 is here. Okay. Then we have 20, 40. 20, 40. Okay, that is my point there. Then the other one, we have 25, 40 again, which will be just there. Now you need to draw a curve through all those points there. You draw a curve through all those points. So it should be smooth, please. Draw a smooth curve. The board is kind of slippery. Board is slippery. Okay, I've missed the point a bit there. Obviously, it's supposed to pass there. Okay, so make it's there. Okay, so that is a curve for the table there. So when you are done that means you have answered the first question. Plot the graph. You get that, eh? So we have plotted the graph there. Question B. Calculate the rate of reaction after 10 seconds. This was supposed to be after 10 seconds. Calculate the rate of reaction after 10 seconds. So remember I gave you the formula for the rate of reaction. where we said rate of reaction is equals to product over the time taken. See that, eh? So what was the volume in this case? So here, instead of product, we're going to put the volume, so because that was volume which was used in that case specifically. So rate of reaction is equals to product or volume over time taken. Now the question is, what was the rate of reaction after 10 seconds? So you go on the graph or in the table perhaps, after 10 seconds, what was the volume? The volume was 25. So the volume is 25 centimeters cubic over the time taken, which is in 10, the time given, time in seconds there. You divide 10 into 25, which will give you 2.5. So the rate of reaction is equals to 2.5 centimeters cubic per second. 2.5 cubic centimeters per second. That is the rate of reaction of after 10 seconds. Okay, the questions are quite easy. The answers, you're just getting them from the table and put them on your answer sheet there. How could you make the reaction go faster? How could you make the reaction go faster? Okay, this is a tricky question, but not that tricky, because here they are just asking you to explain the factors which affect the rate of reaction. If the reaction is slow, how can you make it go fast? You see that, eh? How can you make it faster? Remember the factors affecting the rate of reaction? Yes, please, I need you to leave the answers in the comment below for question C, and I'll be going through to read them as usual. Okay, so today we're going to end here. Next time I'm going to solve other questions concerning the same topic. But if you have questions, please, you can leave questions in the comment below, or you can send them to my WhatsApp line, which is 0972 36 50 11. Then I'll be able to help you. I'll be happy to work with you in person. Okay, so have a good day. And this has been my presentation on the rate of reaction. You can just quickly pause the video and answer that question so that I'll see the answers in the comment section below. Thank you.